The sky turns gray at noon. Then it turns black. Ash falls like snow, but it burns your throat and blinds your eyes. You cannot see the sun for weeks. Your ancestors lived through this, not once, not as a myth, as a real event that nearly ended the human story before it began. Around 74,000 years ago, a volcano on the island of Sumatra erupted with a force no human being has ever witnessed since. Geologists call it Toba. It was not a mountain exploding. It was a supervolcano, a term for an eruption so massive it reshapes climate on a planetary scale. Toba blasted an estimated 2,800 cubic kilometers of rock and ash into the sky. To put that in perspective, that is enough material to bury an entire country under a layer several meters deep. What happens when a volcano that size erupts? The sky darkens first. Then it stays dark. Sulfur particles rise into the upper atmosphere and spread across the globe, reflecting sunlight back into space. Temperatures drop, not for a day, not for a season, for years. Some researchers estimate a volcanic winter that lasted the better part of a decade, with global temperatures falling by several degrees. Plants struggled, animals starved, and somewhere in Africa, small bands of early Homo sapiens were trying to survive it. For decades, one idea dominated how scientists understood this moment. It is called the Toba catastrophe hypothesis, proposed by geologist Stanley Ambrose in 1998. Ambrose noticed something strange in the human genome. Modern humans carry remarkably little genetic diversity compared to other primates, as if our entire species passed through an extreme population bottleneck. A bottleneck means a moment when a population shrinks so dramatically that only a small fraction survives, and everyone alive today descends from that surviving handful. Ambrose connected the timing of Toba to this genetic signature. His theory suggested the eruption crashed the human population down to perhaps just a few thousand individuals. Humanity almost didn't make it. It is a terrifying thought. A single mountain on a single island, nearly erasing an entire species. But here is where the story gets more interesting, because science rarely stays simple. Not everyone accepted Ambrose's theory as the full picture. In 2013, a research team led by geologist Christine Lane examined sediment cores pulled from the bottom of Lake Malawi, thousands of kilometers away from Sumatra in East Africa, where many early human populations actually lived. If Toba had truly devastated the region, the ash layer should show it. What did they find? A thin layer of Toba ash, barely a few millimeters thick, with no evidence of a dramatic ecological collapse around it. The lake sediments showed no sign of the kind of catastrophic disruption a species-ending winter should leave behind. So, which is it? Did Toba nearly wipe out humanity, or did some populations barely notice? The honest answer, based on where the evidence now stands, is that the impact was not uniform. Some regions suffered brutal environmental stress. Others may have absorbed the shock with far less disruption than once believed. What both interpretations agree on is something more important than the scale of destruction. Some humans survived, and the ones who did left behind quiet, physical proof of exactly how they did it. Roughly 6,000 kilometers south of Toba, on the southern coast of what is now South Africa, archaeologist Curtis Marian has spent decades excavating a set of caves at a site called Pinnacle Point. What he found there reframes the entire survival story. Around the time of Toba, and in the tens of thousands of years surrounding it, small groups of humans were living directly on the coastline, harvesting shellfish from the rocks at low tide. Mussels, limpets, whelks. Reliable, protein-rich food that did not depend on unpredictable rainfall or successful hunts. When the world above the coast turned to ash and cold, the ocean kept giving. This detail matters more than it might seem. It suggests something profound about how humans survive disaster. Not through brute strength, not through luck alone, through flexibility. The coast offered a food source that volcanic winter could not easily destroy, because the ocean does not freeze the way inland ecosystems collapse. Small human bands who had already learned to exploit tidal resources had, without knowing it, built themselves a lifeline before the disaster ever arrived. So let's reconstruct what a day might have looked like for one of these coastal survivors. You wake before dawn in a shallow cave, the air thick with a faint haze that never fully clears anymore. The sky above the cliffs has looked wrong for months, a dull gray-orange instead of blue. You walk down to the rocks while the tide is still low. The cold has killed off many of the plants your group once relied on further inland, but the shellfish are still here, clinging to the same stones they always have. You work quickly, prying them loose with a sharpened stone, filling a woven bag before the tide turns. Back at the cave, someone tends a small fire, one of the only reliable sources of warmth left in a world that has grown colder than anyone alive can remember. There is no explanation for what is happening in the sky. No one in your group has a word for supervolcano or sulfur aerosol. All anyone knows is that the old ways of finding food are failing, and the new way, the coast, is not. This is the counterintuitive twist buried inside the volcanic winter story. The disaster did not reward the strongest or the fastest. It rewarded the adaptable. Populations tied rigidly to a single food source or a single territory were the most vulnerable to collapse. Populations willing to shift toward whatever the environment still offered, even something as unglamorous as shellfish scraped off wet rocks, had a far better chance of seeing the ash finally clear. There is another piece of evidence that fits into this same picture. Around Blombos Cave, not far from Pinnacle Point, archaeologists have uncovered some of the earliest known evidence of symbolic behavior in humans, engraved ochre and shell bead jewelry dating back around 75,000 years, almost exactly the window surrounding the Toba eruption. Some researchers argue this timing is not a coincidence. When survival becomes this precarious, when a small group's continued existence depends entirely on cooperation, communication, and shared identity, symbolic thinking may become less of a luxury and more of a tool. Marking group identity, coordinating strategy, passing down which tide pools were safe to visit, and which caves offered shelter, all of this depended on the kind of complex communication that leaves no bones behind, only symbols. Here is the part that should genuinely unsettle you. Every single person alive today, all 8 billion of us, descends from a population that may have numbered in the low thousands during this exact stretch of prehistory. Whether Toba caused that bottleneck directly or simply coincided with a period of extreme climate stress from multiple ice age fluctuations, the underlying fact remains. Humanity's survival through this era was not guaranteed. It was narrow. It ran through small bands on cold coastlines, adapting in real time to a sky they could not explain and a climate they could not predict. Now think about your own life for a moment. You have weather apps that tell you tomorrow's forecast down to the hour. You have supply chains that move food across oceans in days. You have never once had to watch the sky itself turn against you with no explanation and no end date in sight. And yet the instinct that saved your ancestors on that coastline 74,000 years ago is still sitting inside you. The instinct to adapt when the familiar stops working, to try the unfamiliar food, the unfamiliar path, the unfamiliar solution, rather than waiting rigidly for the old way to come back. Every time you pivot when a plan falls apart, every time you find an alternative when the thing you relied on disappears, you are running the same basic survival software that got a handful of coastal foragers through a decade without sunlight. They didn't know they were making history. They were just trying to get through the next low tide. The sky turned gray at noon, once, a very long time ago, It cleared eventually. And when it did, it revealed a species that had learned in the harshest way possible that survival was never about resisting change. It was about being the kind of creature that could bend without breaking, and somehow, impossibly, keep going.